All right, everybody, this is just a little review quickly of what we talked about on Thursday and what was in Thursday's video. We talked about vertex form, but then we talked about this new form of a quadratic equation, and that was called standard form. Standard form is always done in descending order of exponents, so your x squared terms come first, then your linear term, your x to the first power, then your constant term, which is spelled with a C, so we use C for that letter to say that is our constant. And a couple things we talked about is that if you're given an equation in standard form, for example, if you were given the equation or the function f of x equals x squared plus 4x plus 4, we could identify that a is the number in front of x squared, so a is 1, b is 4, and c is 4. And then if we wanted that axis of symmetry, okay, the line that the parabola could fold over on and match up with the left half and the right half, we just have to use negative b over 2a. So let's do negative b, so it's negative of this 4 right here, because that's what b is. Opposite of whatever b is divided by 2 times whatever a is, in this case 1. So we saw this example. Oops, that's a positive 2 in the denominator. So our axis of symmetry is negative 2. Now, I'm going to pull a graph in here so we can kind of take a look at this. So right at x is negative 2. X is negative 2 right here. That's going to be a vertical line that goes right through x is negative 2. And that is the axis of symmetry. Now remember, it doesn't tell us where the vertex is. I do know my vertex has to lie on that line. I just have to figure out how high or how low it is. And the vertex is always located at negative b over 2a, but we just calculated that. It's negative 2. We just have to find out what the value of the function is when x is negative 2. And all that means is to go to this function up here and put in a negative 2 for x. Just substitution. So it looks like this. The f of negative 2 is, where there's an x, says x squared, so it's negative 2 squared, plus 4 times x, so it's 4 times negative 2, plus 4. And this math is in our previous lesson. It's negative 4 plus 4. It looks like the f of negative 2 is 0, and that is our y value. So when x is negative 2, this function's y value is 0, so it goes right through there. Okay, and then we talked about the fact that if a is positive, a is greater than 1, or greater than 0, sorry, positive, it would open up. In this case, a is 1, so this parabola is going to open up. And we don't have to draw it perfect, we're just going to kind of sketch it in for right now. I just know where my parabola starts, and I know the direction it opens. Okay, so this is all from Thursday. Now let's look at some new material for today. I'm going to start with a slide that looks really overwhelming, but don't panic. It's really easy to break down. All right, so we're going to talk about minimum and maximum values. If you think about minimum, minimum means lowest, and maximum means highest or greatest. And so depending on your a value, if your a value is bigger than 0, it opens upward, which means it will have a minimum. What's that minimum value? Well, the minimum is the lowest y value that it goes to. X is where it occurs, the y is the minimum value. You also see we have, because our parabola opens up, because a is bigger than 0, it goes upward, that we have, as we work from left to right, as we come in, it's decreasing, getting smaller, 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 hits its lowest point, and now as we go to the right, it increases. So it's decreasing here to the left and increasing here to the right. Let's look at what happens when a is less than 0. That's the picture on the right-hand side here. If a is less than 0, so the a value is negative, then it opens upside down. All right, as we read, well, first it's got a maximum at this point because it's going to have a highest point. And as we read, x is going left to right like we normally read numbers. It's increasing, then it hits the maximum, then we call it decreasing. Now you'll see this confusing notation here. Okay, it says the minimum value is f of negative b over 2, or the maximum value. Remember, on the left-hand side, a is bigger than 0, so it has a lowest point. And when a is less than 0, it has a highest point. But you still calculate that point the same way. It's just saying take the x value that where the minimum or maximum occurs, that axis of symmetry value, the h value, and just substitute it into the function like we did in the previous problem. It'll tell you what the lowest y value is. So the minimum value is this y value right here. We can say it has a minimum, but if you want the value of the minimum, you have to give the y value. Likewise, if it has a maximum, you have to give the y value. And how do you do that? Just plug in the x where that value occurs, and you'll find it out. The domain, which is awesome. Domain is just what x values can you put into the function. For our parabolas right now, the domain is going to be all real numbers. Okay, that means you can plug any number you want to in for x, but the range is not that. The range is the y values that come out. And it depends on whether the parabola opens up or down, what y values come out of it. If it opens upward, like in this first drawing, then the y values start at that y minimum value and go up forever. So it says y is always greater than whatever that min value was. See, that min value is f of negative b over 2a. We'll look at an example to help explain all this. If it opens downward, then it's everybody less than that max y value. Okay, this decreasing left and right stuff, I think it's best to draw the graph, and you'll be able to tell just reading from left to right. Oh, the graph is decreasing, then it hits the min, then it's increasing. Or it's increasing, hits the min, then it's decreasing. Okay, where does that change from decreasing or increasing occur? It occurs right at that x value, whatever that lowest x value is for the vertex. So let's look at an example to see this in practice. So here's our problem. Let's read through it here. Find the minimum value or maximum value of this function. F of x equals a half x squared minus 2x minus 1. Describe the domain of the function and where the function is increasing and decreasing. All right. So do you have to graph these? No. Does graphing it help? Yes. So I would just right away draw an x and y axis, and let's figure out how to draw this thing. So the first thing we're going to do is find the axis of symmetry. Axis of symmetry, negative b over 2a. Okay, so let's find out what a, b, and c are. This is a, whatever's in front of the x squared, so a is a half. B is in front of the x, so b is negative 2. And c is whatever's hanging off the end, negative 1. So it looks like this. Negative of b, but b is negative 2, so we get this double negative thing going on, over 2 times a, and a is a half. Let's do a little math now. Negative, negative, that's a positive. 2 times a half is 1, so the x value is 2. And that tells me right away my vertex is going to be on this axis of symmetry. This is the line, x equals 2. Next thing is we figure out where that vertex is. How do we find the y value? Well, we just take the answer from the previous set that we just did, this 2, and substitute it into the function. The function is 1/2 of x squared, but x is now 2, minus 2 times x, but x is 2, and then minus 1. Square it first. We can multiply there. 1/2 of 4 is 2. Just cranking out the math here. 2 minus 4, negative 3. So when x is 2, the y value is negative 3, and that is the vertex. X is 2, y is negative 3. I can graph that really easy right there. Now, I could go in and find some particular points, try some x values. I could use the parent function, 1/2 x squared, to generate some points. But I don't need to based upon the questions they're asking. Okay? I know that this parabola opens upward. How do I know that? The a value is a positive number. And if a is positive, in this case positive 1/2, it opens up. A is less than 1, which means it's going to be kind of wide. So it looks something like that. We do not have to be perfect. So let's see if we can now answer the questions. Find the minimum or maximum value. This one has a lowest point, which makes it a minimum. What's the lowest y value it goes to? In this case, negative 3. So it has a minimum of negative 3. Let's see, describe the domain and range. Domain for these parabolas, domain is always going to be all real numbers. You can plug any number you'd like to in for x. The range. Now, since this is a lowest y value, we want to start at the lowest y value and see which way it goes. Well, this always goes up. So we say for the range, the y values are always greater than or equal to that lowest value, in this case, negative 3. Where is the function increasing and where is it decreasing? All right, well, it decreases. This is where it gets a little complicated. If you look at it from left to right, everything to the left, all these negative numbers here, it's decreasing, 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 decreasing until it gets to x is 2. Once x is 2, it starts to increase. So we say it decreases from negative infinity all the way up until x is equal to 2. I'll explain that bracket notation in a second. And then it increases once you get to x equals negative 2. I guess I should leave that open right there, all the way to positive infinity. Now, our book gives a little bit different notation for decreasing and decreasing. In fact, they're trying to make it a little bit simpler, so they just say, hey, it's decreasing left of x equals 2 and increasing to the right of x equals 2. Just know that when x is 2, it switches from decreasing, coming down. That's our decrease section. And then after you get to 2, it starts to increase again. The notation I used says it's decreasing when x is anybody out here. And then it gets to 2. And then at 2, it should be a positive 2. I don't know why I have a negative 2 there. And then it starts to increase. to the right of x equals 2. Here's another example. Let's answer the same questions, okay? Again, if I'm analyzing a graph, if I had Desmos, I'd right away graph the darn thing, but we're going to pretend we don't have Desmos. Okay, let's find that axis of symmetry. By the way, before you even start, you can start to analyze it. See that 4 right there? That's the A value. A is bigger than 0. It's positive. That means it's going to open up. As soon as you know it opens upward, you know it's going to have a minimum, a lowest value. Okay? We also know it's going to be very skinny because of that 4. Very narrow, stretched in the y direction. So let's use that little formula we have. The axis of symmetry is located at negative b over 2a. Let's identify a, b, and c. There's a. There's b. And there's c. So we just go, the opposite of b is 16, negative 16, over 2 times a, and a is 4. So negative 16 over 8, or negative 2. Axis of symmetry, right here. X equals negative 2, piece of cake. Now take that negative 2 and substitute it into the function. 4 times, in place of x we put a negative 2. 16 times, in place of x we put a negative 2. Minus 3. So let's do a little math. It's 4 times 4, minus 32, minus 3. 16 minus 32 minus 3. Holy cow, negative 16, negative 19. So it starts way down here. We'll just put a mark there, call it negative 19. We want to keep track of that one. So there's our vertex. Negative 2 in the x, right here, and negative 19 in the y. Now again, because our objective is not to graph this thing, but to just have a sketch of what it looks like, I already know it opens up. It's going to look like that. So, some of the questions we want to answer now. Question number 1, what is our minimum value? I think that was our first one, minimum. What's the lowest y value it goes to? Negative 19. Let's see here, what's its domain? Domain for these, all real numbers every single time. Range always is going to be something to deal with either that lowest or greatest maximum number. In this case, we have a minimum, a lowest point of negative 19, so our range is all the numbers that are bigger than it or equal to negative 19. Increasing and decreasing to the left of, it decreases. So switch colors there. Decreases left of, in this case, the x value is negative 2, and increases once you get to the right of negative 2. Here x is negative 2, and now it starts to go up. The y value is getting greater and greater and greater. It's not too bad. Let's do one more of these. Here we go. We have a nice little function. It's quadratic. It's in standard form. This is, again, ax squared plus bx plus c. So let's identify our a. Our a is a negative 1. B is a positive 5, and C is that 9 right there. Let's find that axis of symmetry. X equals negative b over 2a, so negative 5 over 2 times negative 1. Negative 5 over negative 2, and I would write that as a 2.5. It's going to be positive. So we know if we're going to graph this thing where x equals 2.5, 1, 2, 3, so 2.5 is right in the middle here somewhere. That's my axis of symmetry. Now I just have to find out what the h of 2.5 is. So wherever I see an x, I put in a 2.5 in parentheses. So let's go ahead and square that 2.5. I think that's 6.25. I think this is going to be 12.5. 10, yeah, it looks like 12.5 plus 9. So that's going to add up to 6.25 plus 9, or 15.25. Now, you can use your calculator and you could just type this all in. It's going to spit out that 15.25. The point is that my vertex is now at my x value of 2.5 and my y value of 15.25. Difficult to graph, but we don't have to be perfect. Just make a mark up here, call it 15.25. Vertex has to be on the axis of symmetry. The negative a value tells me it opens downward, and it's just going to do something like this. Again, doesn't have to be perfect, just a sketch, because now we can tell everything we need to know. Does it have a maximum or a minimum? Answer, it has a max. Where does the max occur? At the highest y value, 15.25. What's the domain? Again, domain, all real numbers every single time. Range, what's the highest y value it goes to? 15.25 and everything down. So y is always less than or equal to 15.25. When does it increase? It increases as I'm going from left to right. It's increasing. So it increases when y is, or x is rather, less than 2.5. That x value right there. And then it starts to decrease when x gets bigger than 2.5. As I get bigger than 2.5, it starts to come down. And there we go. Key thing is, hang your hat on this. Find that axis of symmetry, substitute it in, and that gives you the vertex. Make a quick sketch, and then you just have to interpret your final graph.